Hi everyone, in this video I'm going to show you how to write a net ionic equation for AP Chemistry students. A net ionic equation is an equation that only shows ions and molecules that actually change in a reaction, and they do not include any spectator ions, which are ions that don't actively change in a reaction. They don't form a precipitate, they don't really do anything. They start aqueous, they stay aqueous. And so before we can start writing these, we need to know our solubility rules. And for AP Chemistry, the only solubility rules that you need to know are that anything that has sodium, which is Na plus, potassium, K plus, nitrate, NO3 minus, or ammonium, NH4 plus, those are always aqueous. If it's not one of those four ions, the question will either tell you it's aqueous, or you can assume it is insoluble, unless if you've been told like solubility data or something like that. And so let's just start with writing, and that should say NH4, a double replacement reaction between two aqueous solutions. And so let's say you have aqueous calcium chloride. Now, calcium has a charge of 2 plus, chlorine has a charge of -1, so that will be CaCl2. And that is aqueous, and like I said, the problem told you that was an aqueous solution. And it is mixed with potassium carbonate. Now, the question doesn't need to tell you that potassium carbonate is aqueous because it has potassium in it. We know it's aqueous. Now, potassium has a charge of +1. Carbonate is CO3 -2. So that reaction would be K2CO3. And because it has potassium, it's aqueous. That's a double replacement reaction. And so what are we going to form? Well, in a double replacement reaction, the outside compound, calcium, goes with the outside, or the anion of the other compound. So outside goes with outside. Now, before I write that formula, I need to look at their charges. Calcium has a charge of +2, carbonate has a charge of -2. Those charges cancel out, so it is just CaCO3. And then neither calcium nor carbonate are one of our aqueous ions, so we're going to assume that's a precipitate, or it's solid. Okay, now the other reactant will be, I say inside goes with inside. So the anion of one goes with the cation of the other. And before we write this, we first need to remember that you always write your metal first. So potassium will come first, and then we need to look at charges. Potassium is a +1, chlorine is a -1, so that is KCl. Now, potassium is aqueous, so this substance is aqueous. And then we need to balance our reaction. There are 2 potassiums in the reactants, so I'm going to put a 2 here in front of KCl, and the equation should be balanced now. Perfect. So that would just be my chemical reaction. To write a net ionic reaction, first we need to write an ionic equation, which I'm going to do in red pen. An ionic equation is where you split any compounds that are aqueous, because in a solution, like calcium and these 2 chlorine ions, they're not actually bonded together. Aqueous means that they dissolve in water, so they're separate things. And so let's write that. Because that's aqueous, I'm going to split it into become Ca2 plus, and I do need to write that it's aqueous, dissolved in water, plus Cl minus, chlorine's charge, and that is aqueous. And if we go back to our chemical equation, because there are 2 chlorines in that compound, I need to put a 2 in front of here. That represents that for every 1 calcium, we have 2 chlorine ions, which is what that formula tells me. Okay, plus my second reactant is also aqueous, so I need to split those ions as well because they're not connected, they're separate. So plus K plus, which is aqueous, plus CO3 -2, which is aqueous. And again, that K had a 2 with it, which just means there are 2 potassiums for every carbonate, so I'm going to put 2 in front of that. Okay, arrow. Now for my products, calcium carbonate is solid, which means it does not dissolve in water. The ions do not split apart, so I'm going to write them together. CaCO3 solid. And then plus KCl is aqueous, so those ions are not together in solution. Now, if you have a coefficient like we do here, coefficients carry down into ionic equations. So I'm not just going to write K plus, I'm going to put 2K plus aqueous plus, and remember the coefficient goes to both compounds, 2Cl minus aqueous. And that would be an ionic equation. Now, to write the net ionic equation, you get rid of spectator ions. Spectator ions are ions that are not involved in the reaction. They start aqueous, they end aqueous. They don't do anything. And so looking at my ionic equation, we can identify spectator ions because they are aqueous on both sides of the reaction. And I will circle them in blue. So we have chlorine. No, I did not want to erase that. Chlorine is aqueous in the reactants and it's aqueous in the products. That's a spectator ion. He is not included in the net ionic reaction. The other ion would be potassium. He's aqueous on both sides. He's not included. So what we would include in the ionic equation would be calcium, the carbonate, and my solid. And so to write it, it would just be calcium 2 plus aqueous plus the carbonate ion, aqueous, makes CaCO3 solid. And that would be my net ionic equation. Now, it's important when you write a net ionic equation that you do not forget to write your states of matter. The ions must be aqueous, your precipitate must be solid, and you have to write the charge of the ion. If you do not include the ion's charge, it would be wrong. I hope this video was helpful. Thanks for watching.